Hi guys, today is April 14th and we're going to learn about radian angle measurement today. Okay, so radian angle is measured by, it's a different way of measuring, like we do with length. We can measure in meters, or we can measure in feet, or we can measure in inches or yards, and there's different ways we can measure length with different units. Well, there's the same thing with angles. You guys are used to measuring angles with degrees. But there's actually three different ways. There's one is degrees, one is radians, and one is gradians. Okay, gradians is usually used in engineering. All right, so we're going to learn about radian angle. All right, and what radian angle is, we're going to use this Greek letter. A lot of times we'll use this Greek letter, and it's theta, Theta. Okay, theta, and it's the arc length divided by the radius. So what is arc length? Okay, so arc length is the distance around part of a circle. So this is a full circle. So this right here, from this point right here to this point right here, would be an arc length, and we'll label that S. Okay, and then we also have a radius, which we will call R. All right, and then this angle right here, if we take the arc length divided by the radius, that's going to be my angle theta, and that would be this angle right here. Okay, all right, let me kind of color this in a little bit. So this would be the red length right here. This is part of the circumference of a circle, and this length right here is the radius of the circle, and it's in blue. Okay, all right, so a little bit of color coding there. Okay, so I'm gonna do a little animation to help you understand this a little bit better, okay? All right, so what we have here is a circle, all right? And this is an angle from the center of the circle. C is the center, okay? You can disregard the C right here for right now, okay? But this is the radius of a circle. This is an arc length, okay? And theta, the angle is in radians, would be defined as taking this arc length right here, all right, and dividing it by the radius. And what I've done is I've created a specific circle here where this radius is the same as this arc length. So if we take this, if this is the same length, if this red curved segment right here is the same length as a radius, then we would be dividing the two numbers that are the same, and we would get 1 out of this. So that would be 1 radian. So let me animate this to kind of help you see. So this is my radius right here. You're going to see this move, okay? So watch it, okay? Whoops, there we go. And it's going to move, and it's going to wrap around the circle. And there we go. So that is 1 radian. Why is it 1 radian? Because if you take this arc length, I'm going to get some different labeling up here, so just to kind of ignore that. If we measure this arc length, right, and that's what I have highlighted right here, I'm going to measure it, and it's called arc length, okay, and it's 8 centimeters right now, okay, and then I'm also going to take this radius, and I'm going to measure the radius, so I'm going to find the length of it, okay, and if I take the arc length, all right, and I'm going to do a calculation here. Calculate. There we go. I'm going to take this number, which is the arc length, and I'm going to divide it by the radius, and they're both the same, right? So that's why I'm going to get 1 here. Why is it 1? Because this length and the radius are the same. So I've wrapped a radius around, okay, the circle, and that would be considered 1 radian, okay? All right, so let me finish this up with a different animation to help you see some other stuff that's going on, okay? And we'll come back. For this next diagram, what I want to show you is that we have 2 different size circles, okay? So we have 2 different arc lengths, one right here, okay, and then 1 right here. And then what I want to show you is that this angle, whether you measure it from FGD, okay, it's 57.55 degrees. Whether you go from A to G to C and measure at that angle is 57.55, or you go from D to G to F, because F and D are on the sides of the angle, okay, this angle is the same, all right? And we know that from math too, all right? So I want to show you that for a given angle, right, the radian angle measure will be the same regardless of the size of the circle. Okay, so if we take this right here, the length of arc ABC, that's this length of this arc right here, is 13.25, okay? And we take the measurement, and this is a little bit off a little bit, okay? And we find the radius, which is GA, it's 13.19, and we divide that, we get an angle of 1.00443. So I went out 5 decimal places just to show you the accuracy of this, okay? So this angle right here, it's 57.55 degrees, but it's also 1.00443 radians, all right? So we look at this, that's the bigger circle, okay? If we look at the smaller circle, this arc length is 4.50 centimeters. Well, the radius for that circle is from G to D, and that'd be 4.48 centimeters. And if we divide the ratio, if we divide the arc length divided by the radius, we get the same number as we did up here, right? And we should, because it's an angle measure. It has to be the same regardless of the size of the circle. If you take an arc length and the radius and you divide by them, you will always get the same radian angle measurement. All right. So even if I move this, and we can look at this, okay. So if we take an arc length of, let's say 0, I think I can get 0 here. Okay, 0 angle. Let's see, I don't think I can. It might be the pixels of the, won't let me get right on 0, okay. Well, let's get to like 30 degrees. And we probably won't be able to get exactly 30. I'll try to get it right here. 30.02, okay. So we get, and angle's 30.02 degrees. The radian angle is 0.52400, right? 0.52400, okay? 90 degrees. So these are just some common angles, okay? 90, I can't get right on 90, I don't think. 90.06, okay? Then that would be 1.57179 radians. Look down here, same thing, right? Whether it's from the big circle or the small circle, we get the same radian angle measurement. Okay, and this is going to be the important one that I want to see. I want to go all the way to 180 degrees, okay? So this is going to be really, really important, this idea right here. I'm going to get as close as I can. Right there. Okay, so this is, it's not quite 180 degrees, but look over here, 3.14. That should be a number that you're familiar with. So what are you guys thinking about right now? What number is 3.14? A really common number that you know about. And you may be thinking pi, and you'd be right, okay? So this angle measure at 180 degrees is the same as pi. And I'm going to show you in just a few minutes when we go back to the notes why that's true, okay? So 3.14, the number pi, and 180 degrees are the same thing. In radians, 180 degree is 3.14 radians, okay? All right, we'll talk about that in just a minute, okay? All right, so we're done with this, and we'll go back to our notes. All right, so we're back to our notes, all right? And I want to look at some common arc lengths. The circumference. Now, the circumference of a circle is the distance all the way around a circle, okay? And so we should know from earlier math classes that circumference is 2 pi times the radius, so 2 pi r, okay? Now, we also know that the distance around is 2 pi r. We also know in degrees a full circle, right, all the way around, is equivalent to 360 degrees, okay? So we know 360 degrees is all the way around, okay? Now, what is the angle if we go all the way around in radians, okay? So theta, okay, and it's defined, theta, the angle in radians, is defined as the distance all the way around. We're going all the way around, so it'd be 2 pi r divided by the radius, which is r, which means, okay, this is all the way around, 2 pi r divided by r. The r's cancel here, and we're left with an angle of theta of 2 pi. So what the heck does this mean? This means that 360 degrees is equivalent to 2 pi radians. Now we don't have, we just write radians for the units. Okay, so we don't have like a little degree symbol or anything. All right, and it's going to be really important when you got to make sure, if you mean degrees, you're going to write degrees. If you mean radians, we don't write anything. Okay, so if you say 180 and you don't put degrees on it, that actually means 180 radians. Okay, so you got to be careful. Now we got to start using the proper units on this. Okay, all right. How about a semicircle? Okay, a semicircle is half of a circle, right? So it's going to be half the distance around. Okay, so it's going to be half of 2 pi r. So the arc length for a semicircle will be half of 2 pi r. Well, half times 2 pi r would just be pi r. Okay, now the angle in degrees of a semicircle, so a semicircle in degrees is equivalent to 180 degrees, half a circle, right? Okay, so how about in radians? So what's 180 degrees in radians? Okay, so we're going to take theta, that's our radian angle. Okay, we're going to take our arc length for a semicircle, which is pi r, and we're going to divide it by the radius, which is r for any circle. And what happens to our radiuses here? They cancel, and you're left with pi. Now, this is the most important thing. This is actually what the thing I just showed you, okay, on the diagram or the animation, is that 180 degrees is equivalent to pi radians. Okay, and I want you to box this because this is important. This is equivalent of saying 12 inches is equal to 1 foot, or it's equivalent to saying 3 feet is equivalent to 1 yard. Okay, so 180 degrees and pi radians, 180 degrees, pi radians, they're the same thing. Okay, because of the units, it makes them the same. Okay, all right, we're going to use this to convert. Okay, and we're going to do it's called dimensional analysis, but really what's doing is stoichiometry from chemistry. All right, we're just going to be doing that. Okay, so I'm going to show you how to do that in just a second. Okay, so we'll go to example 1. All right, so for example 1, what I want you to be able to do is I want you to convert 150 degrees to radians. So what is a 150 degree angle in radians? So we're going to start with 150 degrees. So let's write 150 degrees. Okay, so that's equivalent to, okay, and it's 150 degrees times, so we'll put a dot for the times. Okay, now what we want to do is we want to multiply by a version of 1. Now 180 degrees over pi radians, those are the same thing. 180 degrees, pi radians, same thing. Now I'm going to put a fraction here, okay, and we're going to put 180 degrees in the denominator. Now, why do I want 180 degrees in the denominator? Because I'm multiplying by 150 degrees, and I want my degrees to cancel, okay? Now, what's equivalent to 180 degrees? It's pi radians. So I'm going to put pi radians. Now, pretty soon, in fact, actually for the next example, I'm not going to write radians anymore, okay? So, all right, so why can I do this? Because this is a version of 1 because of the units. I'm taking 150 degrees and multiplying it by 1. Now, but it doesn't look like 1. It's not the same. Well, it is the same because of the units. This is radians and this is degrees. And what do we say up here? 180 degrees and pi radians are the same thing. So if I divide both sides of this by either pi radians or 180 degrees, I will get the number 1, okay? So this is a big 1, okay? All right, so this becomes, our degrees are going to cancel here, and you're left with 150 pi over 180. Now, because these end in 0, they're both divisible by 10. So simplifying this becomes really quickly, this becomes 15 pi over 18. And we get some smaller numbers when we divide both the numerator and denominator by 10. Okay, and then we look at this, can we simplify this even more? Yes, these are both multiples of 3. So this becomes 5 pi over, and 18 divided by 3 is 6. Okay, so this means that 150 degrees is equivalent to 5 pi over 6 radians. And notice there's nothing I wrote here, right? Because that means radians. If you don't write it, it means radians, okay? All right, let's do another one, okay? So now we want to do 320 degrees. Okay, so what is 320 degrees? So 320 degrees is equal to, we're going to write 320 degrees again, and we're going to multiply by, okay, so I'm going to multiply by a version of 1. Now, this version of 1, I want 180 degrees in the denominator. Why? Because I'm multiplying by 320 degrees, and I want my degrees to cancel. So I need degrees in the numerator and the denominator for them to cancel. And this would be pi. Now that's pi radians, right? I'm not going to write the radians. If we don't write it, it means radians, okay? So then this becomes 320 pi over 180. Now notice I'm not writing degrees. Why? It's because they canceled, okay? Now again, both of these are divisible by 10, so this becomes 32 pi over 18, okay? And are these divisible by anything else? Yeah, they're both divisible by 2, okay, because they're both evens, right? So this becomes 16 pi, so equals 16 pi over, and 18 divided by 2 is 9. So what is this saying? This is telling us that 320 degrees is equivalent to 16 pi over 9 radians, okay? All right, we're going to go to our next example, and what I want to be able to do is do the reverse of this. So I'm going to give you an angle in radians, and we're going to convert it to degrees, okay? And that's what we're going to do next. All right, for example 2, I want to convert 5 pi over 9 to degrees. Okay, so I'm not saying radians, right? Because if we see convert 5 pi over 9 to degrees, we automatically know that that's in radians, okay? So we're going to start with 5 pi over 9. And that's equal to 5 pi over 9 times, okay, and we want to multiply by a conversion here that will get rid of the radians, and we will get degrees. So I don't want to cancel degrees. So I don't want the 180 down here in the denominator now. I actually want it in the numerator. So, okay, so I know this is 180 degrees, and this is pi radians. So I want to multiply by this, okay? Now watch what happens, okay? So this is going to be equivalent to 5 pi times 180 degrees over 9 pi, right? And what happens now is my pi's are going to cancel, and I'm going to be left with 5 times 180 degrees divided by 9. Now 9 goes into 18, so 9 has to go into 180 20 times, okay? Because 9 goes into 18 twice, 9 would go into 180 20 times, okay? So this becomes 5 times 20 degrees, and 5 times 20 degrees is 100 degrees. So 5 pi over 9 radians is equivalent to 100 degrees. Okay, so I want to go back and talk about this. Why is 180 degrees over pi? Okay, so a lot of times, radian angles will have a pi in it. Okay, a lot of times, not every time, because I have this third example down here that you'll see that we're not going to have one. Okay, and you just have to realize it. But for right now, okay, we see a pi, right? So we want to cancel that pi out. So I want the pi in the denominator because that's my radians. Okay, pi radians. It's not just pi, it's pi radians, and 180 degrees. So whatever you want to get out of this, you're going to put on top. So if like I'm going from radians to degrees, I want to get degrees out of this. I'm going to put degrees on top. In example 1, we wanted to get radians out. Okay, so I put the radian angle measurement on top and the degree angle in the denominator. So if that helps, use it, okay? All right, so this next one is 2 pi over 3. So 2 pi over 3 is equal to 2 pi over 3 times, okay, so I want to get degrees out, so I'm going to put that on top, over my angle in radians, because this is radian angle measurement, so I want this to be radian so that they cancel, and 180 degrees is equivalent to pi radians, okay? So this would be 2 pi times 180 degrees over 3 pi. My pi's are going to cancel, and I'm going to be left with 2 times 180 degrees over 3. Now, 3 goes in 18 6 times, so 3 goes in 180 60 times, okay? So this becomes 2 times 60 degrees, which is 120 degrees, okay? So 2 pi over 3 is equivalent to 120 degrees, okay? All right, so I'm going to slide up to the next one, okay? And we'll do this next one. Okay, so for this next one, we want to convert 5 radians to degrees, and then we want to round to the nearest 0.001. So we want to round to 3 decimal places, okay? So we're starting with 5 radians. And for this one, I'm going to write the radians. Okay, so 5 radians is equal to 5 radians. Okay, so I'm going to multiply by my conversion, okay? And the conversion will be, okay, I need radians in the denominator because I need to cancel my radians. So I need radians down here in the denominator, and I'm going to need degrees on top. Well, do I know a conversion? Yes, you should know a conversion at this point. 180 degrees and pi radians are equivalent. So this is going to be 180 degrees on top over pi radians, right? Okay, so pi radians, 180 degrees are the same thing, all right? So that's my conversion. I am multiplying by 5 radians. My radians are going to cancel, and what I'm going to be left with is 5 times 180 degrees divided by pi, and then 5 times 180 degrees, we could put that into our calculator, okay? And then 5 times 180 degrees is 900 degrees divided by pi, okay? So now we're gonna go to our calculator and we're gonna put 900 divided by pi and see what that comes out to be. What we'll do is we'll type in 900 over pi. And we get 286.4788, so 0.479 degrees. Okay, so we're going to go back to our paper and we'll write that down. All right, so what we know is that this 5, let's write this, 5 radians is equivalent to, and I'm going to put parentheses here, 900 divided by pi degrees, which that is approximately 286.479 degrees. Okay, and that's the lesson for today on angles, on radian angle measurement. What's going to be really, well, I wouldn't say this is the most important thing. As we get deeper into this next unit, okay, this is not the most important thing. So I want you to know that right now, okay? It's finding sine of radian angles. That's what, and cosine and tangent and the other 3 trig functions that you don't know yet, okay? So that's going to be really the important thing, okay? So let me get the assignment sheet out, and I'll say what I want you to do for the assignment for this lesson, okay?